Hey guys, today we're looking at notes for 1.6, measuring the center. The first word that we are looking into is median. So the median is the midpoint of the distribution, which is really just a fancy word for saying middle. Next, if the data values, which we use the letter n, is odd, then the median is the middle number. However, if the number of data values, n, is even, then the median is the average of the two middle numbers. It's really just finding out where is the middle, where is the center. And last but not least, we have the mean. The mean is the average of the data. So this is the average of all of the numbers. Now, we're kind of used to seeing mean because we've seen mean before, where it is you add up all the top numbers or you add up all of the values and then you divide them by the number of values. So we already know what mean is from previous years of schooling. Now, the symbol that we use to represent mean in statistics is this. Okay, that X with the bar on top is called X bar, and we use that to represent the mean. Now, anytime that I give you guys a formula, and I'm about to give you the formula for mean, remember, you know how to find the average. I'm going to give it to you in three different ways. The first way that I'm going to show you is with words. So in words, the mean is equal to the sum of all data values divided by the number of data values. And remember, this is now n. The next way that I'm going to give you the formula is with a little more symbols, but kind of written out. So mean, another way to write mean is X bar. We're going to say the sum of all data values would mean if you take the first data value, add it to the second data value, and then the third data value all the way down to the last one, which is X sub n. And then we're going to divide it all by n. That's the second way that we're going to write a formula. The third way that we're going to write the formula is incredibly shorthand. So we're going to say that X bar equals the sum of X sub I over n. Okay, now there's a couple of symbols that we don't know about, or we don't know properly what they are. The first is this. This symbol is called sigma. It is a Greek letter, and it means the sum. The sum of. So this is the sum of. Next is X sub I. This means that it is an individual data value. Here we go. And there we have the three different ways that you can write the formula for means. So remember, it is just adding up all the top numbers and dividing it by the number of numbers. So now what we're going to do is we're going to look at this example of this kid named Joey. His quiz grades are below. So what we want to know is we want to find the median. So first off, we're going to let X sub I represent all quiz grades. And we're going to find the median. In order to find the median, all numbers must be arranged from least to greatest. Okay, so we want to take all of his grades and we're going to go ahead and put it in numerical order. So the first one would be 73. 77, 79. I'm going to go ahead and do this. If you want to pause and do it on your own, you're more than welcome to. 82, 82, 83, 85, 85, 89. Oh no. Oh no. Oh no, 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 no. 90, 93, 95. Okay, there we go. So then for the median, what we're going to do is we're going to start on the outside and work our way inside. And we're going to try to find the middle numbers. I'm going to go down low. So here, next one, high, low, high, low, high, low. 83. So 83 is the middle number. So our median is 83. Now for the mean, what we're going to do is we're going to take X bar and we're going to add up all of those numbers. This would be a great time for me to pause so I could write everything down. But unfortunately, I don't know how to with this program. So fun. This is so much fun. We're just writing a bunch of numbers. Love these numbers. He got a pretty good amount of scores that were, it's got a wide range. Okay, so now what we're going to do is we're going to count up how many numbers those were. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 different numbers. So we are then going to divide it by 13. So that top number is, I believe, 1,092, but we're going to check just to make sure. So this is 73, 77. Yep, 1,092. I am good. Divided by 13, which is 84. So his mean, his average was an 84. Okay, now let's say that Joey missed a quiz. Oh no, he missed a quiz. What is the new median? So what I'm going to do is I'm going to write out what his data would be with missing a quiz. Now, if he had a teacher like me, he would now have a 0 as a quiz grade until he came into tutorials to make it up. Then I'm going to write all of the other numbers. Squeeze that one in there. I did 9, I did 3, 5. Okay, so now we're going to try to find the middle number for the median. So we're going to go hello, hello. If it's off to work, we go. Oh no, there's two middle numbers, 82 and 83. So because there are two middle numbers, we need to find the average of those two. So we're going to do 82 plus 83 divided by 2. Really what that's doing is trying to find what number is directly in between them, and that is 82.5. Okay, now we need to figure out what the new mean is. So good news, I'm not going to write this out again because I know that this long number is 1,092. I also know that now we have an extra quiz grade, that's a 0. And instead of it being out of 13 tests, this is now out of 14. So we're going to do 1092 divided by 14, which is 78. So his new average would be a 78 until he made up his test. So then the question becomes, well, which measurement should we use? How do we know whether we're going to use the median or the mean as the center? And it all comes down to whether the data is symmetric or skewed. Okay, if the data is symmetric, okay, meaning that there are, or not even, it doesn't have to be perfectly symmetric, but if it is about symmetric, then we are going to use the mean. If the data is skewed, we are going to use the median. And the reason why is because whenever data is skewed, there's this thing called the resistant. And the resistant is the measure of the center when data is influenced by an outlier. Okay, and that concludes 1.6 notes.